Hello everyone, I would like to introduce you wave function collapse algorithm written in PureScript with a little demo. The code is written in pure functional approach, 100% using Claude Code prompts. Now let's discuss what wave function collapse is. Wave function collapse is the algorithm that takes a smaller image and generates a larger image inherited by the rules from the smaller image. For example, what we see here is the smaller building's image, and this algorithm can generate a skyline with a different buildings looking like on the smaller image, but other ones. Or for example, this plant, it also grows larger, but it repeats this in the same way as the plant on the original source image, and so on and so on. For example, this infinite cycle, it keeps the connections of the original form. If it's a maze or Sierpinski triangle or the wool from your favorite 3D shooter in 19s, it can generate everything. The algorithm mostly used for games, because if you have some world map, open world map, and you want to generate a landscape following some rules, for example, that no mountain and river can be nearby unless there is a forest between them. And here we see the example of this rule. It is strictly followed by all the generations. It helps a lot for the open world generative games, for example, but not only, because what is with my internet today? Because you can generate you can use the source data as the integers, for example, and form another integers which you can treat any way you like. It's not only pixels, it's a data or anything you can imagine. It can work not only with images but also with the tile sets. For example, we have some tile set and we define some rules that it should follow. For example, that those tiles should be connected in a particular way, including rotation and symmetry. And here you can see how, with following all the rules, it generates, for example, the circuit board where all the tracks are complete, or all the tracks are connected and no track is broken. Or this open world game map. It also it has some elevations. They have to be connected with some elevation of the ground, and all all the water is connected in a single shape. There is no breaks. It can also be used for three-dimensional generation, as you can see. Okay. How the algorithm works. At first, it takes some random pixel at random position on the output image which it wants to generate, and it treats this position as it has all the possible values, all the possible IDs, or all the possible pixels in this particular cell, and then it suggests a value for this cell and tries to, with every step, it tries to reduce the number of possible values for all the neighbors. No, not all the neighbors, but in some direction. That is important. We will show you this in process. For example, here you can see like this 35 value. It means that there are 35 possible solutions here in this place. And when it started to solve already something, it reduced the number of solutions to, for example, 4 or 18 or 10, and then it proceeds. We call it propagates. Now let's get back, not back, but forward to the actual demo. One moment, please. Yes, here it is. Those are the cats, and we will try to generate as much cats as possible. I already extracted some patterns from here, and I will turn off backtracking for now, so we could see how complex the algorithm can be, because sometimes the solutions, they are impossible to follow all the rules we defined, following all the patterns, and then it gets to the contradiction, and this is this contradiction is this red square you see, because those cats, for example, they are composed in a particular way. No, actually it doesn't care about the cats. It just wants to put another cat, and it doesn't feed between other cats. I hope you get it. I will add backtracking now, which means that when it gets to the contradiction, it not only tries from the start, but also just backtracks in the history. I hope we will get some image in the end. No, we failed. I think it generates from the start all the way. Let's do it from the very start. This track history thing, we could navigate all the steps before. If we press pause, for example, I have this history of all the generations. It uses a lot of memory and a lot of processing power. That's why I have this checkbox here, which you can turn off. Oh, it one step at a time. Let's continue. yeah, you see, in the end it failed to fill in the cat at some place, and it starts to go back and forward all the time, more and more back and more forward, but still it fails. This is actually a complex example because it contains cats, and cats are sometimes angry when you try to put them in a box, just sometimes. Yeah, it's kind of infinite tries. Let's try something else. We have a lot here. This square is actually, yes, the city generator. Will we get to the city? That's also hard. Yeah, this should be simple or not. So yes, the algorithm can fail sometimes, as you can see, but this time it's solved because it depends on how strict the rules are. We could configure a lot here, like if we have periodic input, which means it treats it like the infinite image, which continues, takes the left edge and adds it to the right edge, and so on and so on. And while we were talking, the maze was generated. What we also have here, and which is also more interesting, like this circuit example, because we have rules here that which determine how connected should be the pieces, the tiles, and those are the only combinations allowed, but including symmetry and rotations. So this rule doesn't only mean that this tile and this tile should appear at left and the right of each other, on the left and on the right of each other, but also it could be rotated and below, exactly below this one, which is also rotated. Let's try this one. As you can see, it solves quite fast. And yes, we can navigate all the generations, and here you can see how the process was going. The more light is the squares here, it means the more percents of the image was solved. And as like I showed you, those examples, those pieces are reducing to less possible options. It means it is decreasing entropy. Because wave function collapse algorithm, it is the the very smart name for this algorithm. It's something from the physics, and it means that if you observe a quantum, you reduce the solutions it can find, it can come to. I don't know, it's very complicated, so it's just the rough explanation of the algorithm. So yeah, actually there are a lot of demos like these, and what's interesting is probably the code which was made by the Claude AI. Yes, this is the code. It was actually pretty good in it. I don't have a lot of complaints about the code, because it split it into modules like I asked it to. It created these small modules. For example, the algorithm itself, wave function collapse, it can do. It takes a wave. Wave is this frame of possibilities which we cycle through, which we propagate through. It returns either a contradiction, and of course it's an affect. It's an affect because it's a Taylor Carson. It's either a contradiction or a next state. There is also a function collapse with a retry, so it means that it attempts to find a new wave all the time, and it means like the contradiction is always trying to resolve, so there is no sense in storing it. Also the backtrack module, which is used only if we enable backtracking. A lot of comments as usual, but they seem to be fine. A catalog is the catalog of patterns. It found also the pattern origins and weights. Maybe it could be like the map, maybe not the fastest way to find things, but it works pretty okay for now. Also it uses web workers, that's why I can pause it at every moment, and it doesn't overweight CPU or GPU a lot. So yeah, this is the collapsing part. All this open source. You can see what it did. I did no corrections, because usually in functional programming community we try not to use these awful symbols like brackets, and we try to use as much operators as we can, like no brackets anymore, and this is beautiful. But the way it was written was ugly. Sorry, I get it back. It sometimes mixes the building. Should be fine soon. So yeah, maybe it's not a lot of code. Something could be reused here. It was smart enough to use sets, like the sets of unique pattern IDs for the algorithm, but maybe it's because I asked it to be very smart and be very precise. And when you ask Claude Code to be smart, it is very, very smart. Smarter than me, unfortunately. This is for reading tile sets. This is the actual wave, which contains the cells, and the cell, as you can see, is probably could contain all the possibilities, the set of unique pattern IDs inside, and maybe it duplicates some information, or no, it remembers the directions, neighbors, whatever. So yeah, it looks like this. Be welcome to try it any way you want. Yes, my idea is to put it on a server so it could solve all the things indefinitely, so it could go into the loop and never return. But it can be useful. Thank you for your attention. I hope it was brief. Bye.